Dear learners, I am glad to introduce myself. I am Dr. Sindhu, Assistant Professor, Department of Food Processing Technology, PSC College of Arts and Science, Coimbatore. I welcome you to this e-learning module on chocolate manufacturing process. In this module, you will learn the basics of chocolate, a brief description of the raw materials used, and the steps involved in chocolate manufacturing. Chocolate always remains as one of our favorite foods unanimously. Of course, everyone concedes that it is consumed by people across the globe and the only product having zero haters. These are the items of impulse purchase competing with categories like soft drinks, snacks and beverages for a share of the consumer's wallet. The cocoa, chocolate and confectionery industry employs hundreds of thousands of people around the world and is a key user of other agricultural commodities such as sugar, dairy products, nuts and fruits. Let me now explain the basic definition of a chocolate. According to Food Safety and Standards Authority of India, chocolate is a homogeneous product obtained by an adequate process of manufacture from a mixture of one or more of the following ingredients, namely cocoa products including cocoa beans, cocoa nibs, cocoa mass, pressed cake, and cocoa powder with or without the addition of vegetable fats other than cocoa butter, and sugars, milk solids including fat. The material shall be free from rancidity or off odor, filth and adulterants, insect and microbial infestation, particularly fungus, and any harmful or injurious matter. Next, let me describe on the characteristics of the raw materials needed for chocolate preparation. To prepare good quality chocolate, superior quality cocoa butter, sugar, milk and milk products and emulsifiers are required. Let us see one by one in detail. First comes the cocoa beans, the most essential ingredient for chocolate making, which are the seeds of the small tree botanically known as Theobroma cocoa, which is native to South America, Brazil, West Indies and Sri Lanka. Cocoa beans are rich in fat than protein and carbohydrates, and it is an excellent source of essential vitamins and minerals. The other potential substances in cocoa beans are theobromine, caffeine and polyphenols. Cocoa in the form of cocoa nibs, butter, liquor and powder can be used for the manufacturing of chocolates, out of which the primary ingredient is the cocoa butter. Cocoa butter is the natural fat of cocoa bean which is obtained from well-winnowed cocoa nib after grinding and pressing. According to USDA, it is the edible fat obtained from sound cocoa nibs before or after roasting. It is a pale yellow liquid with characteristic color and flavor of cocoa and not greasy to touch. It is brittle at temperature 25 degrees Celsius and softens in hand and melts in mouth. It is rich in fatty acids like stearic acid, palmitic acid and oleic acid. There are three grades of cocoa butter. The first or the premium grade is the prime pressed cocoa butter in which fat is obtained from good quality cocoa nibs and will not be subjected to further refining. The second grade is the expeller pressed cocoa butter. In this, the nibs are steamed and the butter will be extracted and refined. This is mostly extracted from substandard cocoa beans. The third grade is the solvent extracted cocoa butter, in which solvent such as hexane is used to extract butter from cocoa powder and then it is refined. Hence, it has bland taste and flavor. From this, you can understand that the prime pressed cocoa butter is a fine or the premium quality one which shall be used to produce superior quality chocolates. Next important ingredient is the sugar. High grade good quality dry sugar should be used for chocolates. It should be free from invert sugar. Dextrose or anhydrous corn syrup are used as partial replacement for sugar. However, Non-sugar substances like sorbitol, mannitol and xylitol are occasionally used as sweeteners in dietetic chocolates. The next ingredient is the milk and milk powder. Whole milk powder and non-fat milk powder are the primary milk products used. However, in some countries, whey is permitted instead of milk. Milk powder should be used as soon as possible and do not be stored in open hoppers. An important additive for chocolate is emulsifier, in which lecithin is widely employed to reduce viscosity and usage of cocoa butter. It is obtained from both animal and vegetable sources with the highest content in egg yolk, followed by soybean oil and least in butter. Other sources are peanut, cottonseed, corn, safflower and rapeseed oil. Now I am going to explain the most important topic, the chocolate manufacturing process. The steps involved are preparation of ingredients, mixing, refining, conching, tempering, molding, cooling, demolding, cooling and packing. First step is the preparation of ingredients, in which cocoa nibs and sugars must be pulverized either before mixing or by using a machine with combined grinding and mixing action. Cocoa butter and other fats should be liquefied, whereas milk powder or cocoa powder must be dried and sealed well before mixing. The second step involves mixing of the prepared ingredients. The ingredients are metered and fed into mixers. In continuous mixers, the ingredients are fed continuously with a high degree of accuracy over long period. Small errors during weighing bulk ingredients like sugar, cocoa liquor and milk powder may have significant effect on the production and quality of final product. Similarly, errors during dispersing fats and additives like emulsifiers and flavors may produce serious consequences. Hence, batch mixing is considered more positive, since errors in the delivery of the raw materials to the mixer will have less effect on the condition of whole batch and can be corrected. In any batch mixing process, it is important to establish a precise mixing time to obtain a homogeneous consistency. This process should produce a chocolate paste of somewhat rough texture and plastic consistency. If the texture is too slack, the paste will not line the rollers properly during refining, while stiff paste retard the passage between the rolls. The third step is refining. It is the process of reducing the particle size of both cocoa solids and sugar crystals in finished chocolate in the range of 15 to 25 micron with slimy texture. The refining machine employs 5 rollers mounted almost vertically, one on the top of the other. The gap or the distance between the rollers is accurately adjusted in order to obtain the highest refining fineness. From the first to the last roller, the rotating speed is progressively increased, so that while moving from the slower roller to the quicker one, that is, flowing from bottom to top, the product is also crushed and stretched. The rotation speed is approximately 0.75 for the first roller, 1.25 for the second, 1.80 for the third, 2.45 and 3.70 meter per second for the fifth one respectively. Apparently, it should be guaranteed that chocolate particles have maximum size of less than 25 micron on refining. Next process is conching. It is the process of stirring or mixing the chocolate for an extended period of time using conch pot. The conch pot consists of a flat granite bed upon which heavy granite rollers are attached to robust steel arms which moves backward and forward. Conching is done at 60 degrees Celsius for 96 to 120 hours by traditional method, which improves smoothness, viscosity and flavor, and it also disperses solids completely in the chocolate. It removes moisture and undesirable volatile acids through evaporation and reduces the acidity and particle size. The conched chocolate then undergoes tempering. Usually, the cocoa butter consists of fats with varying melting temperatures. Some of these fats melt at low temperatures and the others melt at high temperatures. The fats that melt at high temperatures are of course the first one to solidify, which gives high quality chocolate with shine and snap. Untempered chocolates take a long time to set and the texture will be grainy and the surface looks cloudy because some of the cocoa butter floats on the surface and make a whitish coating called bloom. Hence, tempered chocolate sets quickly with a good shine and texture. Tempering consists of 3 steps: melting, cooling and pre-warming. The temperature for dark chocolate is 50 to 55 degrees Celsius and for the milk and white chocolate is 45 to 50 degrees Celsius. This melted chocolate is then cooled or decrystallized. Once the chocolate is tempered, it is ready for molding, dipping and other purposes. Therefore, tempering acts as a preliminary step to all other chocolate processes. So, whenever we do any chocolate preparation, we use tempered chocolate. The tempered chocolate is then subjected to molding. It consists of casting liquid chocolates into mold. There are 3 forms of molds available. One is solid block, next is hollow shells or figures, and the third one is the filled shapes. The molded chocolates are then allowed to cool and then it is demolded. The demolded chocolates are cooled again and then packed and distributed. I hope that you are clear about the steps involved in chocolate manufacturing. Let me summarize what you have learned in this module. According to FSSAI, chocolates are the mass obtained using cocoa, sugar and milk, and it should be free from contaminants, rancidity and infestation. The ingredients that are required for the fine quality chocolates are cocoa butter, milk powder, sugar and emulsifiers such as lecithin. You have also learned the steps involved in chocolate production, including mixing, refining, conching, tempering, molding, cooling and packing. Hope this module gave a clear idea on the techniques involved in the manufacturing of chocolates and will benefit you. Thank you for your patient listening.